thank you very much for coming. I am really happy to be here in Frankfurt, but also really happy to be talking to you about one of my favorite topics, which is serverless technologies, and most specifically with Azure. So Azure Cognitive Services, Azure Functions, and Azure Logic Apps, and how we can use all of those in the world of Umbraco. So a bit about me. My name's Callum Whyte. I'm on Twitter. I tweet a lot. Follow me if you don't already. I'm an Umbraco Master and an MVP. I host Umbraco-Festival. You may have seen it earlier today with Martin. And I do a load of stuff around the community as well. I speak at quite a few events and organise some too. And I really, really love donuts. They're probably one of my favourite things in the world. So maybe this is going to be like a whistle-stop tour over some of these technologies. I'm not going to go into too much detail because I could talk forever. So let's grab a drink in the bar afterwards or something, and we can talk about some practical uses. Maybe you have experience with them. But some terminology up front that you're going to need to be aware of. Microservices is this idea of separating your application and components into individual deployable applications. So kind of grouping by domain and making sure that all of the code relating to one specific purpose exists in one place and it's separated from your other code. Serverless is this idea of running your code only when you need it and not having to manage any infrastructure or servers. And Logic Apps is kind of an abstraction on top of that that gives you a really nice user interface for managing some of these serverless applications, and you can almost write code without writing code, or write logic without writing code. I've kind of mentioned a bit of this, but what are microservices? It's a bit of a buzzword. It's been around, it's been spoken about around the industry for a very long time. But essentially, it's decoupling elements of your domain, key features maybe, separating those out into individual services, and those run all in isolation and kind of get glued together by one big mesh over the top. They're independently maintainable, and one of the big plus sides here is that you can actually write a whole system in 5 different languages, because each service can be written in the language that is best for that developer or best for the use case. So if you were doing machine learning or something, you might do Python, or maybe like physics stuff, you might do Python, but you could do Java and any language and run them all as part of one big system. It makes things a lot easier to maintain, in theory. You don't really need to take your system offline when you do a deployment. Right now, I'm sure people who have Umbraco sites know, oh, okay, we're going to do a deployment. You tell the content editors, hey, stop touching the site, or you then maybe put up a holding page whilst you deploy. I don't know if anyone's still doing that nowadays, but this is generally the way. Whereas with a microservice system, because everything is decoupled, you can take one component offline and the whole system itself should still continue functioning. It also just gives you a little bit more comfort in being able to work with the tech that you specifically want to work with. This is a huge diagram of a pretty big microservice system. It's an example from Microsoft's a big tech post that Microsoft have on using Docker and a few other technologies around in a microservice setup. This kind of gives you a pretty good idea of what a microservice setup would look like. So here we have this API gateway, and this manages all of this is the public interface for your services. And then behind that you have these different independently managed mini applications. And this gateway routes the relevant traffic to the relevant place so you can get the end result to the user. And it might be that some of these then perform a task that needs to be to give data to another service that then needs to pick that up. And we use a thing called a queue. So in this scenario, that's something like Azure Service Bus or End Service Bus. And that's a big list of tasks. You put some data on there, another service can pick up that data, process it, and do whatever is needed to get the result to the end user. This way we don't have dependencies between services. They're kind of all dependent on the service bus, and then they don't really know about each other. So they raise some data, and the other service is expecting that data and just picks it up and off it processes stuff. We're not really going to go into too much detail about microservice architecture today, but this kind of gives you a background on why serverless and why Azure Functions. So realistically, serverless is for building event-driven applications. When I do this, then this code must execute. The fantastic thing about it is you only run the code when you need the code to run. Whereas with, I don't know, we might have a console app running on a server and it's just constantly checking for changes, but this doesn't do that. This waits to be kind of notified, it needs to start up, the code runs, and as a result, you only pay for when your code is running. You pay per execution. Most serverless cloud computing models will charge you for like per 200 milliseconds or per 100 milliseconds of execution, and for the amount of memory and RAM you use. So in reality, you don't pay for any idle time, it's just when your code is running. This idea that you just bring your code, you don't need to bring the platform or any hosting environment with you. You just chuck your code at it and it runs. You don't really have to care about performance too much because it should infinitely scale. And it should be resilient too. So if you post a message up onto a queue that's then processed by a function, if that function fails, the message is still there and it can be replayed later. Similarly, application insights in Azure gives you really good detail over what's been run or what has failed, and you can go back and investigate things. So it adds a kind of another tier of resilience that you don't really get if you're running your own version of this or even self-hosting it. And then finally, we get to fire all the DevOps and IT people because no one needs to manage services anymore. I've mentioned a couple of times Azure Functions, but there are alternatives. If you are not an Azure person, there is AWS Lambda. It's been around quite a bit longer than Functions. I'm a Microsoft guy, so I stick with Functions. It's my preference, but there's also Google Cloud Functions, and they all do pretty much the same thing. In Azure Functions, it's really matured quite a lot over the past year, probably. It started off where you could run, they'd supported C#, F#, and JavaScript out of the box, meaning you could just chuck your JavaScript code or your C# code up there, and it would run without any issues or complaints. They've now added Java. That came out literally last week, and they have in preview PHP, PowerShell, and Python, which is really cool. So they're really rapidly scaling up the kind of languages and code you can run. Some big names that use Azure Functions specifically would be ASOS. Do you have that in Germany? I assume. Cool. ASOS. For ordering clothes, they handle all of their transactional stuff through Azure Functions. So when you create an order, they put that data onto a queue, and then they use that to trigger a lot of different code to say, notify this supplier that they need to ship something, print a shipping label, send the customer an email to say, we have received your order. And that all happens through Azure Functions. Domino's Pizza, delicious, fantastic example as well. They do all of their order chain from order to delivery entirely through Azure Functions. And I think this is something, if you follow Troy Hunt, you'll be aware of. He's been pretty vocal about his use of Azure Functions for Have I Been Pwned, a service where you can go on and search for passwords in data breaches, see if your passwords maybe been leaked before. The entire API is now driven through Azure Functions, with some caching on top as well. And as such, he's been able to massively reduce his hosting costs, massively reduce the complexity and worry of having to host an application that the API gets like tens, hundreds of thousands, maybe millions of hits a day. So it's pretty popular. I mentioned that everything's event-based. So there's a few different triggers that these functions have, these actions that need to occur in order for your code that you've given it to run. So that would be an HTTP event. That's just a URL that the function then gives you to say, hey, hit this, and then my code will run a web API, if you will. Timer-based, so maybe you want something to run on a schedule. This is perfect for scheduled tasks, or just something you want to kind of check on every once in a while. Storage-based triggers, so this would be an event. I've uploaded something somewhere, then action this code. And a queue-based system, publisher and subscriber-based model. So your function sits there listening to a queue, waiting for some data to appear in that queue. It's subscribed to the queue. When the publisher, my application, posts some data, the subscriber, my function, triggers and executes. All of this is made possible by something called Azure Event Grid, and it sits across all of the Azure infrastructure and notifies everything when something happens. So you can even detect, like, I've created a new web app in Azure, trigger all of these functions, or I have uploaded a file to blob storage, trigger all of these functions. It's dirt cheap. It's insanely cheap. And especially if you compare this to having a server sitting there for 24 hours a day, 365 days a year, it costs next to nothing. You're only paying per execution. They give you, Azure give you a ton of free credits to use each month too. So that's you pay 20 cents per million executions. If you think about how many times your website gets hit in a month, and if it's less than 1 million, chances are you can run some of your logic on functions and it won't cost you a single thing. Additionally, you pay per gigabyte seconds of processing power you've used, but it's like a billionth of a penny that you pay per gigabyte second. So it's really, really cost effective. I actually estimated how much it would cost Domino's to run their ordering process, or all of their orders in the UK through Azure Functions. And it would cost, if we're saying it's about 250 million orders a year, and there's 5 steps in an order from placing the order, it's gone to the kitchen, collection by the driver, delivery type thing, then the average cost per order is like tiny. We're not even talking a penny because of the scale that they'd be doing this on. And another example, this is Troy Hunt's Have I Been Pwned API stats. This is actually quite out of date numbers. He did a talk at Microsoft Ignite where he shared how he'd scaled up infinitely and it cost him like $35. So again, this is costing him $32.75 a month to serve whatever this is. Yeah, billions of megabytes, seconds of data. Now, Azure Functions, you can develop them locally, and it's just a console app that they represent the data to you as. And it comes up with this lovely ASCII art logo as well, which I love. So yeah, it boots up as a console app, regardless of what your trigger is. And then that app is watching for an event in order to get running. And we're going to have a quick look at how that looks in Visual Studio and also the Azure portal for getting started. IBM, constantly. Okay, I will jump to the Azure portal because it will be a little easier. You can actually create functions directly in the Azure portal or through Visual Studio. Similarly, if you create them through the portal, you can come back later and download that and run it in Visual Studio. So it's maybe easier just to create a resource straight in the portal. I can create a resource here called a function, and it's a function app you want. You click create, and you have to give it some. You have to give it a name. In this case, this is Umbraco-Festival Deutschland 2019. I have a resource group that I can put us into. You can choose whether you want to run on Windows or Linux. Because they don't actually run .NET Framework, they run. They now run .NET Framework. They no longer run .NET Framework. It's now .NET Core. So you can run your .NET Core code on Windows or Linux. It doesn't matter. But you'll see here there's a ton of different runtimes you can run on. So that's .NET for C#, F#, JavaScript. They have experimental TypeScript support as well, if you're interested in that. So I'm going to create one in West Europe. I'm going to use .NET for this example, and I have a storage account already, which I can. Let's just let it create. Within a few seconds, this is going to create a function app, and that is my container for hosting anything that I need, be that a C# app over here and a JavaScript app over here, it's not a problem. There you have a really nice editor experience, or a development experience for functions, both in Visual Studio and through the Azure portal. You can actually code your entire C# function directly through the portal, and you get kind of IntelliSense and all kinds of other stuff. It's not full-blown C# files or classes that it's creating, it's actually C# script, which means they interpret it at runtime. Whereas if you build and compile in Visual Studio, it's a DLL and it's actual C#, so it then runs on. Oh, it's taking some time today. It then runs when you deploy it to Azure. Under the hood, this is the exact same technology that's used by Azure Web Apps. It's based on the old Web Jobs framework or infrastructure that they built, and it's deployable in a ton of locations worldwide, and doesn't really matter where you deploy it to, because you can spin file up if you really want to. It succeeded finally. So I've now created my function app, and within this I can start creating functions. A function has a few templates for getting started. And you can choose what you want to do. Do you want to download the Visual Studio solution, VS Code, or do something in the portal? In this case, I'm going to create it in the portal. And it gives me some pre-defined examples of a function, maybe a webhook or a timer-based thing, and they have an absolute ton of them. In this case, we're just going to create an HTTP endpoint so I can demonstrate. Straight away, this will dive me into the code, and I'm going to be able to, yes, it's created this HTTP trigger, and I'm going to be able to edit this code directly in the browser. This has already spun up a URL for me that I can hit, and we will see. I need a query string on there. This is just standard .NET Web API. It's taking in the HTTP request, and it's after a query string of name, and it's going to then pump that out in the result to me. So I can go here, and name equals UFD19. Hello, UFD19. So in a matter of seconds, I've been able to spin up a sample .NET app. You'll notice here it's also using, it's calling in Newtonsoft JSON with a slightly interesting syntax you may not have seen before. This is the #r says install this NuGet package for me. So we're actually now able to install NuGet packages and then use those directly in a function. You can edit this and change this to your heart's content. This can do whatever you want. Like I said, there's a ton of different other options. You don't have to write this in .NET. But that was a very quick look at just getting started with a function. Now, actually, where does this apply to our Umbraco sites? This becomes slightly complicated. Because it's not running full-blown .NET framework, we can't just install Umbraco onto the function and run all of our stuff there as if it was a content app, a console app, sadly. But we could use it for the additional processing that we need to do on the side. Just like I was saying with microservices, it's about building a resilient system. We do a lot of stuff in our Umbraco websites that perhaps could be more resilient. A good example of this, I think, is sending emails. How many times you have maybe a checkout form or a contact form that goes away and sends an email? What happens when your SMTP server goes down? The user gets a YSOP probably. No one knows if the email has gone through or not. Perhaps you retry on your side, but it just hangs indefinitely. What we could do is we could post things like emails that need to be sent, or data that needs to be sent to a third party, like a CRM, and even handle scheduled tasks with functions. We can push the data that we need up into Azure onto a service bus, and our service bus our function can watch that service bus for some data and then process when it needs to. I think emails is a fantastic example of this, because so often you hit submit and it takes ages to do anything. It's like, why? Why am I being held up? this would be my kind of catch-all advice. Anything that's non-critical for that user as part of that transaction, offload it somewhere. Because if it can happen later, it doesn't matter right now. If one component breaks, I shouldn't be held up from using your system. You can go in later and replay when you've fixed the bug or the problem that's stopping it going through, and they can get their confirmation email or something, maybe an hour late, but they don't get held up on the inside. Now, how can we use these within Umbraco? This is an example of how to push some data to a queue. It's 3 lines of code, and in actual fact, most of that code is me building up a message. I give a queue client, I pass a connection string for the queue that I have. That could be on Azure, or it could be self-hosted, it's up to you. And then this queue client just sends my object. That object is the data I want to pass on to my functions. You could do this as part of anything, really. You could put this in a controller, a C# controller, and write your own logic. You could do it as part of an application event in Umbraco, or if you're in V8, a composer, so you could do all of that in there. Or even a forms workflow. I'm saying about submitting emails and then holding up processes. Well, why should you hold up an Umbraco forms submission because your email's taking time? Push it onto a service bus, process it later. Using Umbraco in a function isn't possible, I've said that. That's a shame. However, Umbraco headless is standalone, and they have .NET Standard APIs, or .NET Standard library that you can run within a .NET Core app or an Azure function to access data. So if you weren't tied to using a self-hosted Umbraco site and you just wanted a way of maybe managing some data that you want to build up an email in your Azure function to then send on, well, you could use Umbraco headless. I know it's in beta right now, and this all might change, but by installing this NuGet package into your function and then including the Umbraco headless client, you should be able to get data out of Umbraco and then kind of content manage parts of your function if you wanted to, which is pretty cool. And like I showed you with the #r syntax, you can pull in any function or any NuGet package namespace. Durable functions. Now, I think this is where functions get really, really powerful. This is a relatively new feature. Everything I've showed you so far is about an event happens and an action occurs. But what if you maybe have a chain of actions that need to happen? So I have submitted my order form. I need to tell the warehouse to prepare the order. I need to print the printing label, the shipping label, and I need to send the confirmation email. Those are all dependent on each other. Until the order is being created, I can't send the confirmation email. But if one of those processes breaks, the user shouldn't be stopped. Durable functions effectively lets you do this with one line of code, which is fantastic. It inherently handles resilience of retries and failures. It helps you avoid creating tightly coupled functions because you just create a function for each bit of code that you would have written, or maybe each method you would have written in your .NET code before, and call them directly in a resilient way. You can use orchestrator functions, which are really powerful. Perhaps you want to start sending emails when you reach a certain threshold. This would be, you can set some conditions to say, once I've got 1,000 items queued up, then send the emails. So it sits there constantly watching and waiting for that threshold to be reached, and then it will run. You could say the same. You could do the same thing for reporting. Maybe you run a check every 24 hours to build up some reports, and you produce a list of emails you need to then send. And once you've built that list up, once it reaches 1,000 items, send it. I said it's easy, and I genuinely mean it's really easy. I say I inject my durable function context, my durable context, and I say call this action. I give it the name of the function I've created, and then any parameters or data I need to pass to it. So maybe you need to run some logic beforehand to get some other data, and that will execute when your logic is true and it's all good to go. So we've just looked at how we build that kind of logic in code, but there's a really powerful feature, and I think this might be my favorite thing in Azure for a very long time, called logic apps. And this lets you build workflows effectively and define conditions and logic and glue together already pre-built functions without having to write a single line of code. It's just configuration. And we'll have a quick look at it. Just like I created my function app, I can go in and I can create a logic app. And a logic app under the hood is just going to build a function for me. It's actually building the code. But I only deal with a specific UI. I've already created this logic app for this event, and it gives you a really nice UI to build your logic. You have to have a connector, which in this case is a resource you need to watch for a change. So that would be our trigger before. That was HTTP or a queue or some kind of other event. In this scenario, I've created a blob storage event. And what I'm doing is I'm watching the blob storage account that I've tied to my Umbraco website, so that when I upload a new image, I want to go and do some processing. This trigger was added by going to my logic app, going to the logic app designer, and then choosing my trigger. I put some configuration in there to say I want to check this /media folder, and I only want to ever check one item at a time, and I want to check on this kind of schedule. So you can choose here to say however often you want. You then start building up a chain of logic. So I can add an action, or I can add parallel branches of processing. Maybe I want to do 2 or 3 things at the same time. These actions come with a whole bunch of pre-built stuff. You've got conditions, if statements, for each loops, and you can even start building up strings and variables. Maybe you want to build an email, for example. There's community submitted actions as well. You could develop your own. I've not really dived into that too much. What I've done here is I've actually already wired up this tool, which allows me to, when I've uploaded an image, pass that off to cognitive services and get some data back. Perhaps I want to, when I've uploaded an image to the Umbraco Media Library, check that check that the name matches the description of the image or something. This is something you wouldn't want holding up the user of your CMS, but can maybe happen separately and send a notification email or put a task on a queue somewhere else to then go and fix. Here I'm taking my image that is uploaded, the URL, passing that off to cognitive services, and hopefully getting a response. The fantastic thing about this is I can run everything in the browser, and I can even debug through it entirely through the browser. I am going to cheat slightly and just upload directly to the blog, but I have an image of a cat, and the cat is going to be uploaded to my blob storage. Now my logic app here is going to check every second that some data has been added to my blog, which it has. And once it runs, we'll then get to see a stack. Oh, and it's failed. We'll get to see a nice trace of everything that logic app has done. So if we just take a quick look in here, we can see all the data that the event gave to my logic app. This could have been data you've passed from Umbraco to a service bus or to a queue, then processed. And then this data gets passed on to my next step, which was to cognitive services, and it doesn't seem to like. I think I've probably not made the image URL public. That's a shame. What this would have done is it would have come back and said, a nice response from cognitive services, here's your response, this image is a cat. And then I can do whatever processing I need to do with that, send an email, yeah, anything. And that's it. I am pretty much bang on time. It was a pretty quick whistle-stop tour of what Azure Functions and the serverless stuff in Azure can do for you. I kind of hope it's opened your mind to see maybe places you could put this into your own websites. And as I said, I'm more than happy to have a chat afterwards about some ideas or if you want more information. Thank you very much for listening.